Hi children, today we are discussing our chapter motion. Okay, in the previous class we discussed about the problems relating to average speed and average velocity. Then we move on to the next topic, that is rate of change of velocity. Rate of change of velocity. Okay. We studied that what is speed. What do you mean by speed? Speed is the rate of change of distance. And what is velocity? Velocity is the rate of change of displacement. We already studied that speed is the rate of change of distance and velocity is the rate of change of displacement. Then what is the rate of change of velocity? Here we know when a motion takes place, suppose an object moves. At first the object moves at a velocity of 5 meters per second, that is from at first 5 seconds the velocity is 5 meter per second, and in the next 5 seconds the velocity is 10 meter per second, and in the next 5 seconds it is 15 meter per second. Here the velocity changes as the time passes, and at the same time the velocity can be decreases. Here the velocity increases, and the velocity can be at 5 seconds the velocity can be 10 meter per second. Next 5 seconds it may become 8 meter per second. The velocity may become 8 meter per second, and in the next 5 seconds the velocity can become 5 meter per second. That is, here the velocity of the object increases. Here the velocity of the object decreases as the time passes. The velocity of a body increases or decreases with time. Increases or decreases with time. That is, there is an idea by how much amount velocity of the body changes in unit time interval. That is, the amount of velocity changes. The amount of velocity changes, that is, increases or decreases. The amount of the velocity of a body changes in unit time interval. That is the acceleration. This is a new term for you, that is acceleration. Acceleration is a physical quantity which determines how much amount velocity of a body changes in unit time interval. Or simply we can say the definition of acceleration is rate of change of velocity. Acceleration is the rate of change of velocity. This is the definition of acceleration. Acceleration is the rate of change of velocity of a moving body. How can we write the equation of acceleration? We already said that acceleration is the rate of change of velocity of a moving body, or change of velocity in unit time. That is equation for acceleration. Equation for acceleration. Acceleration is equal to rate of change of velocity, that is change in velocity in unit time. That is, acceleration is equal to change in velocity in unit time, that is by time. Okay, that is change in velocity. That is, when I take a time of 5 seconds, at the start of this 5 seconds, it has a velocity, and at the end of 5 seconds, it has a velocity. That is, at the start of 5 seconds, that is initial velocity, and at the end of the 5 seconds, it is the final velocity. So we can write it as change in velocity is equal to final velocity minus initial velocity, all divided by time. Here, acceleration can be denoted by the small letter a. Okay, that is equal to final velocity can be denoted by the letter v minus initial velocity u, all divided by time t. This is the equation for acceleration. Okay, acceleration is equal to change in velocity by time, that is equal to final velocity minus initial velocity. A is equal to v minus u by t. Then what is the SI unit of acceleration? We already said that acceleration is change in velocity by time. The unit of velocity is meter per second divided by time. Here is second. That is, we can write it as meter per second square. So the SI unit of acceleration is meter per second square. Okay. The SI unit of acceleration is meter per second square, and the equation is A is equal to v minus u by t. Then, is acceleration a vector quantity or scalar quantity? Yes, acceleration is a vector quantity. It has both magnitude and direction. Then we can discuss different types of acceleration. That is, the first one is positive acceleration. What do you mean by positive acceleration? Positive acceleration, from the name itself we can understand, that is, when the velocity of a moving object increases with time. Here positive means the velocity of the moving object increases. We already said that acceleration is a change in velocity by time, but here in positive acceleration, the velocity of a moving object increases. That is, here the change takes place, increasing the velocity. So, positive acceleration means the velocity of a moving object increases with time. Okay, while traveling in a straight line, then acceleration of the object is said to be positive. Then what is negative acceleration? Negative acceleration is opposite to that of positive acceleration. Here the value of acceleration will be A is equal to always be a negative value. That is, here the velocity, the change in velocity is negative. That is, the velocity of a moving object decreases. Here the velocity of a moving object decreases. Then how can we define it? That is, when the velocity of a moving object decreases with time, then the acceleration of the object is said to be negative. Okay. Hope you understand the negative acceleration and positive acceleration. Then the next one is zero acceleration. Then what is zero acceleration? In positive acceleration, the acceleration is always positive. In negative acceleration, the acceleration is always negative. And in zero acceleration, the acceleration will be 0. The value of acceleration will be 0. When will the acceleration become 0? Time cannot be 0. Here change in velocity is equal to 0. That is, there is no change in velocity happens. In 0 acceleration, there is no change in velocity. That is, the velocity is same always. That is, the velocity is constant here. The velocity is constant here as the time passes. That is, at first 5 seconds it has, at 5 seconds it has 10 meter per second. In the next 5 seconds also it has 10 meter per second. In the next 5 seconds it has 10 meter per second of velocity. That is, here as the time passes the velocity does not changes. There does not has change in velocity. So the velocity is a constant here. Then when the velocity become constant, here acceleration will be 0. This is 0 acceleration. If the change in velocity of the object for any given time interval is 0, that is, when the object is at rest or moving with a constant velocity with the time, then the acceleration is said to be 0. Okay. Then the next one is uniform acceleration. Uniform acceleration. What do you mean by uniform acceleration? We already studied about uniform motion. What is uniform motion? Change in position of the moving object is equal in equal intervals of time. Then the object is said to be in uniform motion. Then what is uniform acceleration? That is, here at first the 5 seconds it is 2 meter per second. Then next 5 seconds it is 4 meter per second. Then next 5 seconds it is 6 meter per second. In next 5 seconds it is 8 meter per second. That is, here the value gets, here the velocity gets increased at each 5 seconds is 2 meter per second. The velocity increases at 2 meter per second at every 5 seconds. Is it correct? Okay, that is, the change in velocity is equal in equal intervals of time. Then the object is said to be in uniform acceleration. Okay, hope you clear that. The uniform acceleration. The example for uniform acceleration is a ball motion of a freely falling body. Motion of a freely falling body. Freely falling body is uniformly accelerated. Freely falling body has, it is very important, freely falling body has uniform acceleration. That is, when I throw a ball upward, it has uniform acceleration. Here the change in velocity is equal in equal intervals of time. That is, the acceleration is constant here. Okay, then it is uniform accelerated motion. Then we can, the next one is non-uniform acceleration. That is opposite to the uniform acceleration. That is, here in uniform acceleration, the change in velocity is equal in equal intervals of time. Here in non-uniform acceleration, the change in velocity is not equal in equal intervals of time. Then the object is said to be in non-uniform acceleration. That is, here the example is freely falling body is an example for uniform acceleration. For non-uniform acceleration, we can say an example, that is motion of a car on a crowded road. These are all about the types of acceleration. These are all about the types of acceleration. That is positive acceleration. Here the velocity increases. That is, the acceleration will have a positive value. In negative acceleration, acceleration will have a negative value. That is, change in velocity is decreases. Here 0 acceleration, the acceleration will have a value of 0. That is, the change in velocity with time is a constant. Then uniform acceleration, the change in velocity of the moving object is equal in equal intervals of time. Here in non-uniform acceleration, the change in velocity of the object is not equal in equal intervals of time. Hope you clear that. Here it is very important, freely falling body has a uniform acceleration, uniformly accelerated motion. That is, freely falling body has a uniformly accelerated motion. Then we move on to the next section, that is, we have to do some problems related to acceleration. First, we can start with a simple problem. That is, a car starts from rest and picks up a velocity of 18 meters per second in 10 seconds. Calculate the acceleration of the car. Here says that a car starts from rest. That is, the car starts from rest means the initial velocity, that is, the car starting, the velocity, initial velocity means the velocity at which the motion starts. Okay, so the car starts from rest here, so the initial velocity can be denoted by the letter u, that is equal to 0 meter per second. Then, and picks up a velocity of 18 meter per second, that is the final velocity v is equal to 18 meter per second. That is happened in 10 seconds, that is t is equal to 10 seconds. Then calculate the acceleration, that is we have to find the acceleration. Acceleration a is equal to, we know the equation for acceleration a is equal to v minus u by t. That is, here v is 18 minus 0 all divided by 10. Then 18 by 10, that is equal to 1.8. Here acceleration a is equal to 1.8. What is the unit of acceleration? Meter per second square. Okay, the unit of velocity is meter per second and the unit of acceleration is meter per second square. Then we move on to the second question, that is, a train starting from rest moving with a uniform acceleration attains a speed of 90 km per hour in 5 minutes. Find its acceleration. It was given a train starting from rest. That means u is equal to, initial velocity u is equal to 0 meter per second. Then it attains a speed of 90 km per hour. That is, v is equal to 90 km per hour. Then the time it is given 5 minutes. 5 minutes. Here the 5 minutes can be changed into seconds, that is 5 into 60, that is equal to 300 seconds. Then here the velocity is given in kilometer per hour, so we have to change it into meter per second. How can we convert the value of velocity in kilometer per hour into meter per second? Do you remember that? That is, in order to change kilometer per hour into meter per second, we have to multiply the answer in kilometer per hour into 5 by 18. It gives the answer in meter per second. Here v is equal to 90 kilometer per hour. That is, v is equal to 90 into 5 by 18. That is approximately equal to 25 meter per second. That is equal to 25 meter per second. Then we can calculate the acceleration a is equal to, the equation for acceleration a is equal to v minus u by t. That is equal to, here v is 25 minus u is 0 by t 300. That is approximately equal to 1 by 12. What is the unit of acceleration? Meter per second square. So the acceleration of train is 1 by 12 meter per second square. Hope you clear that. We move on to the third and last question, that is, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle come down to 4 meter per second in the next 5 seconds. Then calculate the acceleration of the bicycle in both the cases. That is, the question is, first, starting from a stationary position, that is, the bicycle at rest. The bicycle starts from rest. Starting from stationary position means the bicycle starts from rest, that is, initial velocity u equal to 0 meter per second. This question can be divided into two cases, that is, it is the first case, case 1. U is equal to 0 meter per second and attain a velocity of v is equal to 6 meter per second. Attain a velocity of 6 meter per second in 30 seconds, that is, t is equal to 30 seconds. In first case, we can calculate the acceleration. We know acceleration a is equal to v minus u by t, that is, v here is 6 minus 0 by t. T is 30 seconds, that is 6 by 30, that is approximately equal to 0.2. The acceleration is equal to 0.2. Then what is the unit of acceleration? Meter per second square. This is the answer for the first case. In the second case, it said that then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Here the initial velocity u is equal to 6 meter per second. Before applying the brake, it has 6 meter per second. Okay. In the next case, the final velocity become initial velocity and then comes down to 4 meter per second. By after applying the brake, the velocity become 4 meter per second. Okay. Then in the next 5 seconds, that is 4 meter per second, in the next 5 seconds, that is t is equal to 5 seconds. Then we can calculate the acceleration. A is equal to v minus u by t, that is equal to v here is 4 minus u 6 by 5, that is equal to 4 minus 6, we know minus 2 by 5, that is equal to approximately equal to minus 0.4 meter per second square. The unit is here, the acceleration is minus 0.4 meter per second square. In the first case, the acceleration is 0.2 meter per second square. In the second case, that is, he applies a brake here. In this case, he starts his journey. He starts to pedal the bicycle. Here he applies the brake, then the velocity decreases to 4 meter per second. That is, from 6 it becomes to 4. Okay, then the acceleration become negative. That is here negative acceleration. We get the negative acceleration. Hope you understand what is acceleration, the equation of acceleration, SI unit of acceleration, types of acceleration, that is positive acceleration, negative acceleration, zero acceleration, uniform acceleration and non-uniform acceleration. And hope you understand the problems related to acceleration. In the next class, we will discuss the graphical representation of motion. So we need the graph. We need to represent the motion in graphs. So you have to buy a graph book for the next class. Okay. Hope you understand all. We will continue in the next class. Thank you.